Welcome back to our deep dive on Matter. Today we're talking with Peter Pirc, right? Is that the right way to pronounce it? About UWB, ultra-wideband technology, and how that's going to be used in smart homes, and specifically, is there anything we can do with Matter using UWB? So let's start with a general discussion about ultra-wideband, kind of how it works and why it is suddenly of such interest in consumer applications.
Yeah, indeed, Bill. So UWB has been there for a while. I met with this technology for the first time in the late 90s when it was intended to be used for a fast data transfer, pretty much something like a Wi-Fi today. And then a few years back, technology was revived to fill in the gap on the precise positioning. And this technology is then being used for the indoor positioning of people, for item tracking, for secure car access, and the physical access. And this all triggered also integration of the ultra-wideband into mobile phones. And consequently, after a few generations of mobile phones with ultra-wideband out there, we have a large infrastructure that is a perfect thing to leverage for the IoT use cases.
Yeah, so it looks like precise ranging, that is distance measurement, is kind of the killer app here, at least for now. And let me see if I get this straight, how this actually works. So UWB works by sending out very, very short pulses of energy over a fairly wide frequency band, right? For a wide range of frequencies. And because of the shortness of the pulses, you can calculate time of flight very accurately. It's the speed of light, but it turns out transistors are really fast these days. So you can actually compute to pretty good accuracy how far away something is, right? And so that seems to be one of the biggest use cases for this. That two-way accurate ranging, accurate down to what? Maybe a few centimeters?
Yeah, so we managed to go down with the accuracy down to the plus minus 10 centimeter. You know, the next generations of our chipset will come down to the plus minus 5 centimeter of accuracy, which is actually giving a very good accuracy for a lot of use cases that are enabled with the phone.
So what are some of the compelling use cases that you see, particularly from a consumer point of view, given that we have a lot of interest in things going on inside the home, and the technology is built into pretty much all smartphones now?
Yeah, so the most compelling use case is, of course, the item tracking. So everybody knows this situation where you misplace your keys or some other item, and then if you have, let's say, the keys attached to a key fob that has ultra-wideband integrated, you can leverage the fine precision finding of the mobile phone functionality, meaning that you can leverage the arrow navigation to your lost keys, or you can leverage the AR navigation with the camera that will pinpoint down the location where the keys are located. So that's the most compelling one. Of course, you can attach these key fobs to many other things, right? To the items that you misplace and you care about. And then we have the smart car access that is working with the mobile phone and the car, and is actually enabling a very secure way to access your car compared to how we're accessing our car today. And then we have the various versions of the access. We have the physical access for home or for corporate environment, and we have logical access. So today we know the physical access, which is like with the NFC or with the fingerprint, but adding the ultra-wideband really adds the way how we're gonna enter the buildings, or how we're gonna use these doors of the future. It means that you will just grab the handle, and prior you arriving to the place where you can grab a handle, the whole credential exchange will be actually done, and based on the precise location, precise spatial awareness, the door lock will say, okay, Peter is coming here, right? He's close enough, now I unlock the bolt and he can enter. And then we have the use case of logical access that we are also demonstrating at the CES this year. So it's about having the logical access to devices that we use in everyday life. For example, the laptop, so the PC that we are using, to seamlessly log on to the laptop by leveraging, of course, the credential exchange between the laptop and the phone, and also in a secure manner, and also the distance or the spatial awareness in front of the laptop. And additionally, what is new this year, we are introducing also the functionality of the UWB sensing. So UWB radar or UWB sensing is actually adding the functionality that was not really exposed so much until now, but it is very useful as a companion to the UWB ranging applications. So here at the CES we are showing an example of that, where we do the logical access to the laptop with using a phone or a wearable. But then once you're there with the unlocked phone, and for example you forget your phone on your desk and you go and grab a cup of coffee, you leave your PC unattended. And here the radar sensing, the UWB radar sensing is actually enabling to make the presence detection. Is there somebody in front of the PC, somebody with a heartbeat, somebody with breathing? And if not, of course, the screen can actually, or the laptop can lock accordingly. So that's something about the use cases that we see right now, and we are working on, and we expect soon to launch. But there are also many other use cases that are related, let's say, to UWB payment or to the leveraging UWB for the transit applications. But this is actually our long-term vision, where we think that UWB is going to evolve to. It's very important to mention that all of these access applications and also the payment and the transit of the future, they will be secure ranging based. Secure ranging based means that it will leverage the technology that we have on the secure elements, so embedded secure elements in phones, in cars, and also in door locks. And we're going to leverage this also to secure the connection over ultra-wideband.
So you not only exchange the ultra-wideband signals, but you know exactly which device sent it.
Correct.
You can be sure that you know which device sent it.
Correct.
Yeah. Back to the radar thing for a minute. That has home applications too, right? I mean, you know, there's ways to do location sensing using cameras, but I don't know about you, but I don't really want cameras on all the time in my house. That's probably not a real good idea from a lot of different standpoints. So can you use it for that?
Yeah, I mean,
presence detection in a home?
Yeah, so for example, the smart home applications, or let's say I would put it this way. So the home is a place where you come to relax, right? To get a rest, to enjoy. And this is also the place where you do not necessarily carry your phone with you at all times, right? So you actually put it on the charger and then you say, okay, I'm going to watch some TV, listen to some music. And here are the use cases that come into play that are not an interaction with my mobile phone, but they are more like interaction device to device. So a very good example is you have a home cinema system of audio speakers, and those audio speakers are not firmly mounted somewhere, right? But sometimes they are misplaced, and also you want to arrange it that is best actually for your living room environment. And when those speakers have ultra-wideband embedded, and they can actually measure the distance to the other speakers and report this information or report this floor map to the signal processing unit of the sound system, it can enhance the sound for this particular configuration. Okay, so this is a device.
That's great. I can think of other examples of where that would be really handy, like knowing the physical location of something to a fairly high degree of accuracy within the home, right? I mean that's extremely useful.
Correct, yeah. And we can go further, right? So we are not carrying a phone with us when we are at home, but some devices, some smart home devices, need a position of a listener or a person that is watching TV. So it's a very good example for the UWB radar use case, that the TV, so the smart TV wants to know the presence of somebody who is watching the TV in front of the TV. And like you mentioned before, You can do this very easily with a normal camera, right? But nobody wants to have a camera on top of the TV, right? While watching, while chilling out and relaxing. And UWB radar sensing here is definitely providing enough information about people, or about the person being present in front of the TV, making a kind of approximate location, but still ensuring the privacy, right? So it does not know, it does not recognize my face, but it knows that there is a person, and that the TV and the sound system can shape the experience accordingly.
Let's shift gears for a minute and talk about how a product manufacturer would integrate this technology into their products. An OEM or whatever can use NXP technology in their products. The Trimension family is mentioned a lot as being UWB enabled. Can you explain what it takes to put UWB into a product?
Yeah, that's a very good one. So, so we have different kinds of UWB interaction, right? Let's start with the most common one, where you have a phone that interacts to some of the smart home or IoT device. So if I'm doing, for example, the smart speakers, right? Then I can leverage our Trimension's IoT products, which come with the full FIRA certified, that is ensuring the interoperability with mobile phones. And then leveraging that, I have the whole communication between my device and the phone actually on a certified level, meaning that you are sure that all the signals are actually compatible and it will pretty much work out of the box. And then when you go further, integrating the ultra-wideband into your different sizes of the speakers, right? You can also leverage the modules from our module partner, meaning that you don't have to develop the whole RF design for every different size of the speaker and so on. You can simply take the modules from our partners, integrate it once. The modules come pre-certified on FIRA, on the FCC, and you can leverage this then to build different SKUs or even different devices.
You mentioned FIRA and FCC. Can you give us a real quick overview of kind of what the regulatory situation is here, not just in the US, but worldwide, for the frequency bands that you use, and can you deploy worldwide, and stuff like that?
Yeah, so first in terms of standardization, so we have two main, let's say, consortium that is taking care about the UWB use cases. Right? The first one is the Car Connectivity Consortium that is taking care about the use cases related to the car access and around the car. And the second consortium is the FIRA Consortium, so the Fine Ranging Consortium, that is taking care about the use cases of ultra-wideband in IoT space. So, and both consortiums are taking care that there is interoperability and a firm specification for various use cases. And then you made a question about the regulatories. Of course, UWB is still a radio, right? Impulse radio, transmitting signal. It has to fit into some of the specifications. So we have customers who are shipping worldwide, right? Which means that with our chipset and with our technology, you are able to pass all of the regulatory requirements. But in terms of the particular on the frequencies, so we have in ultra-wideband we have about 16 channels which go across the frequency from very low to I think above 10 gigahertz, and we are leveraging right now mostly the channel 5 and the channel 9. So FIRA Consortium, for example, is leveraging the channel 9, which is in a range which is above 6 gigahertz, which allows a lot of headroom towards the other technologies which are on the lower band, which means that it has a kind of a reserve space for the operation, and we have a lot of headroom to the channel 16 that we can leverage for the future.
Nice. I guess one final question I just have to ask: what do you think is next for ultra-wideband? Is there anything you can tell us about what you're working on in the lab to kind of go beyond where we are today? What should we get excited about long term here?
Yeah, so I mentioned a bunch of use cases that are wrapped around the ranging, right? The precision location, precision finding, and so on. So these are the use cases that will pretty much be implemented very soon. One big thing is what we are presenting at this CES is the UWB radar sensing. And this UWB radar sensing does not need to run on a separate device, it runs together on one device that also does ranging. And this allows a whole new set of applications, not only the presence detection as we are showing here, but you can do many, many, many more things with the data that you acquire from this radar functionality. And here, it's going to be also on our customers a lot, how they're going to leverage this functionality and how innovative they're going to be to implement the use cases that we cannot even imagine today.
That's pretty exciting stuff. Can't wait to see how this all works out. Peter, thank you so much.
Thanks for having me.
And please join us for other videos in this series as we explore the technical details of Matter and smart home technologies in general with industry experts such as Peter.